All right, now to contrast with what's going in. So we're going to take a look at it here just to better understand what goes where, what each one of them is doing, and what purpose they serve. So starting off with the main radiator, as you can see, the overall size of the radiator is the same as a stock one because it's meant to go in the stock location. But you can see the thickness of it. I mean, it's about 3¾ inches, 3¾ thick. So you have a whole lot more fluid capacity there. We also have here what's called an auxiliary radiator. So both of these units here are going to be for your engine coolant. Okay, that's their only purpose. There's no oil going through it. It's not cooling anything else but the engine coolant, right? So they're going to be routed in series. So what's going to happen is you're going to have coolant coming from the motor, hot, being pumped out. It's going to come first through the bottom auxiliary radiator here. It's going to feed through here. This is more of a heat sink, really. So it goes through here and around, and then it enters the bottom of the main radiator, goes through the core, comes out the top, back towards the engine. Now, the big thing here is volume, right? Your total fluid coolant capacity. The more coolant you can have in a system, the cooler it will stay, because it takes longer for you to go through all of that fluid before it warms up. So that's just the coolant part of the engine. And then to the sides here, because we now have a different bumper, we have, bigger openings that we can utilize. Now we'll go over this other stuff. So these are what we call the cheek coolers here on the side. As you can see, there's two of them on each side. These front two, the bigger one, the thicker one there and there, that's going to be our heat exchangers for the twin turbo system. Now, this car does not use an air-to-air intercooler. I chose to go with a air-to-water system for a couple of reasons. Number one, I didn't want to block the already, challenged openings that we have for the engine cooling. So by going to a water to air, I can have not one gigantic air to air cooler in front of everything, but I can utilize the sides and put smaller, more compact water to air coolers, which are more efficient. Water is 8 times more efficient of pulling temperature from the coolant as opposed to air. So as you can see, they're massive for what they are. These were custom made here, custom end tanks on them. They have -12 AN fittings on the sides. I mean, they hold about 2 gallons each worth of coolant. So that's massive in itself. You can see here from the side how thick they are. Now, the guys behind them, they're oil coolers. They were actually made by a company called Improved Racing. They're extremely high quality stuff. So basically what they are, one of them is going to serve the purpose of an oil cooler for the engine. The other one is going to serve the same purpose for the transmission. And the reason they can be mounted like that, one behind each other, is because this is all about delta, right? So you have a cooling system in front of it that once the air goes through here is probably going to be coming in through, somewhere around 250 or so. If these coolers do their job properly, which I highly doubt that they won't, it should get air back down to ambient temperature before it goes through the back set of your oil, which doesn't require as much cooling because your oil can run a little warmer than your coolant. You actually need it to be at a certain temperature, because oil has a working temperature. It can't be too cold. So that's the reason why they're mounted in that sequence. So now you have divorced systems. You have a complete cooling system for the motor. You have a completely separate cooling system for your twin turbo application, or it could have been a supercharger or whatnot, but in this case, for your twin turbos. And then you have this guy sitting right here. This is actually going to be the core. I have to fabricate the end tanks for it still once I start the turbo system. But this is actually your water to air intercooler core. And although compared to the other stuff, it doesn't look as big, but this guy here is massive for its purpose. This is made by CSF. They claim this to be good and efficient to about 1,500 horsepower to the wheels. So we're talking here, you know, around 1700 horsepower or so, which is just slightly over what we're shooting for with this car. But overall, this is the layout that you're going to have in the car, more or less. That center section is going to be mounted more or less the way you see it. That radiator is slanted down towards the front, so it forms kind of like a V, so air gets trapped in between them, and it's either got to flow through the top one or the bottom one, because there's going to be ducting, you know, shrouds that separate these that come straight out. These are going to be shrouded where they come, and they utilize that full opening of the bumper so no air spills can happen. And these are actually going to be vented right through the wheel wells. So the back side of that is where your wheel is, and air gets discharged through that, which is also a good thing because you are not dumping hot air inside the engine bay where everything is already hot. But there you have it. You can get a good look at it. There is a lot going on there. There is a lot of fluid capacity on every single aspect of the build, which is a great thing. You know, the goal here is to be not a jack of all trades, but an ace of all trades. You can take this thing anywhere you want, and I'd be very, very comfortable with it, you know, as far as keeping your temperatures in check. So that system right there, and I'll get this guy here, and I'll lay it over here so we can get a good comparison of what you're replacing. And that's your cooling system right there.